Let's do questions 5 and 6 and just look for the variation. So notice this equation, both of these equations are set up like the other two. We have a r is equal to, I don't know, some number a plus or minus b times, in this case we have sine of theta. And let's just look at the rectangular graphs and see how this is going to be perhaps a little bit different. So for question 5, we still have a sinusoidal axis at 2. Our amplitude is still 2, so we know we're going to go up to 4 and down to 0. And the only thing that's different is that our sine is negative, so that we know that when we graph this, we start on the sinusoidal axis, but they're going to head down. So we're going to have something that looks like this. And let's see what this looks like when we sketch a polar graph. So what I know is when theta is equal to 0, our r value is 2. When theta is equal to pi over 2, so when this is due north, r is going to be 0. And r is positive, so I know we're going to be graphing in this quadrant. By the time we get to pi, so when we're facing due west in this direction, r is going to be 1 again. And when we're facing due south, so at 3 pi over 4, r is going to be 4. So here we again have a cardioid. We have sine in this, so this is symmetric over the y-axis, and it's just flipped from what we had in question 4. And let's do the same thing. Let's explore with question 6. So here our sinusoidal axis is at -2, and our amplitude is still 2. Except that we're going to start by heading downward. So we're going to start on our sinusoidal axis. And what we're going to end up doing is heading all the way down first, right? And then back up to the middle, and then we'll be at 3 pi over 2, we'll be up at the top. So we're going to have something like this. So when we go to sketch our polar curve, well, this is a little challenging because r is only negative here. So when we're facing due east, our r value is going to be -2. And as I swing through this quadrant, r is going to be graphing in this quadrant. So I'm going from 0 to pi, and r is going from -2. By the time I'm at pi over 2, r is at -4. So I'm graphing in that direction. Between pi over 2 and pi, so I'm swinging through this quadrant, but I'm going to be graphing in the opposite quadrant. By the time I reach pi, my r is -2, so we're up to here. By the time I am at pi over 2, again, I'm swinging through this quadrant, but graphing in this quadrant. By the time I'm at, 3 pi over 2, r is 0. And by the time I'm back at 2 pi, r is back at -2 again. So isn't this interesting that this starts in a different place, but that the graph in question 6 looks exactly like the graph in question 5.